Good morning and welcome to lesson 7.7, writing exponential functions. Today we're going to be talking about three different concepts: exponential growth, exponential decay, and compound interest. So it's to your advantage to have a calculator out as I go over each of these formulas with you and explain them in great detail. So let's go ahead and talk about the exponential growth formula first. Exponential growth. Thank you so much. Appreciate your help. The exponential growth formula says y equals c times the quantity 1 plus r to the power of t, where c is the initial amount, where r is the rate of growth. The rate of growth. And let's give you an asterisk. You have to change a percentage to a decimal. And on time, we're going to give you another asterisk. Time is the time in years. So if it said 6 months, it would be 0.5 or 1/2 years. Yes?
What's the R?
The rate of growth. Rate of growth. Sorry. So, exponential growth formula, y equals c times the quantity 1 plus r to the power of t. This is the rate at which something is growing. Okay, so let's think for a minute. Things that can grow exponentially. What can grow exponentially? Anybody have a guess? What can grow exponentially? Yes? Money. Your finances. One good investment in the stock market before it crashes. That would work. What else could grow exponentially? A population. How about bacteria? A bacteria could grow exponentially. We've seen that before in problems where there might have been so many bacteria present on day 1, and on day 7 there's an outright explosion of bacteria. So one more time, the exponential growth formula is y equals c times the quantity 1 plus r to the t. C is the initial amount either of your money, the initial amount of a population, the initial amount of bacteria. R is the rate of growth. It's extremely important that we change it from a percentage to a decimal, and t is the time in years. Okay? So let's go ahead and let's do a problem. Obviously, there are more things that grow exponentially, and as we think of more, we will be happy to add them on. So I'm going to actually do the first problem in our notes. The population of Johnson City in the year 2015 was 25,000. Since then, the population has grown at an average rate of 3.2% each year. Write an equation to represent the population of Johnson City since 2015. So basically, right now what they're asking is for us to just go ahead and write an equation. They're not asking us to find what the population is in a certain year. That will be part B of the question. So let's go ahead over here and let's look. The initial amount was 25,000 people. The rate of growth was 3.2%. You change the percent to a decimal by moving the decimal point 2 places to the left. Technically, you're dividing by 100, which gives me 0.032. The time in years is 10, and we'll need that for part B. But part A says just write an equation for t years for growth. So the initial amount replaces C. The rate of growth was 3.2%, which is 0.032. We add 1 plus 0.032 together, and the equation that we come up with is y equals 25,000 times the quantity 1.032 to the t power. Now we're going to take this problem one step further. Now they want to know, what will the population be 10 years from now? 10 years from now. So basically, I don't have to rewrite everything because I already have my equation. So the only element that I have to place in is I have to put in a 10 for t. So this would be y equals 25,000 times the quantity, 1.032 to the 10th power. Okay, now listen carefully when you do this. You're going to do parentheses and exponents. And do not round. We're not rounding. Everybody take your calculator out. So what you're going to do is clear that calculator, clear the memory. Excuse me. You're going to type in 1.032 to the 10th power. And when you do that, you should get a full screen. It should say 1.370241046. Can you confirm that that's correct? Yes. Okay. Do not round. So you're going to go parentheses, exponents, do not round, and then you are going to multiply that times 25,000. So everybody multiply that times 25,000. And we should get y equals 3.425.6 point, if we were going to round that, 0.03. But we're talking about people, right? So if we're talking about people, we don't have a fraction or a decimal. We would round up. If this were a 5, it's not. So the population would be 34,256 people. How many people are with me? Do you understand the concept? It looks a lot worse than it is. So I just want to go on record as saying, on my test, I will give you the formula. However, you need to know how to apply it. So something that's growing exponentially will be 1 plus the rate of growth, as compared to something that's going to decay exponentially would be what, guys? Not 1 plus, but 1 minus. Excellent job. Very well done. Okay, so let's go ahead and look at our next problem. Okay. Anybody have a question so far? So that's exponential growth. Exponential growth. Before I go on to exponential decay, I want to take a minute and talk about a formula that actually is derived from the exponential growth formula. Now, I know you spent some time on this last year in Mrs. Rain's class, and this is the compound interest formula. Compound interest formula. So we're going to look at example 2 in your notes. I'm going to work it for you, though, from top to bottom. The compound interest formula is A equals P times the quantity 1 plus R over N to the power of N times T. P is the principal or the amount that you're investing. R is the percentage rate, and you're going to go from a percentage to a decimal. N is the number of times your interest is compounded annually. And T again is the time in years. So let's give you a little lesson here in English. If it says annually, that's 1 time per year. If it says semi-annually, that's 2 times per year. If it says quarterly, that's 4 times per year. And if it says monthly, that's 12 times per year. Does everyone understand? Annually is 1, semi-annually is twice, quarterly is 4 times, and monthly would be 12 times. Okay, so let's go ahead. I'm going to read the problem for you. I know it's in your notes, but let me read it for the sake of everybody that's listening. The Garcias have $12,000 in a savings account. The bank pays 0.5% interest on savings accounts, compounded monthly. Find the balance in 3 years. So now what we have to do is we have to pick apart and decide what's the P, the R, the N, and the T. All right, so how much money do they have in their savings account? $12,000. $12,000, or an example 2. What is the interest rate that they're getting? 0.5%, and that has to be changed to a decimal, which would be what, guys? 0.005. N is the number of times that the interest is going to be compounded. It says compounded monthly, so how many times are they going to get interest per year? 12. And they want to know how much money are they going to have in that bank. That's assuming they put $12,000 in, they leave it, they don't add anything, they don't take anything out. After how many years? 3. And now we just make the formula work for us. So we're going to go A equals 12,000 times the quantity. 1 plus R is 0.005 over 12 to the power of N, which is 12, times 3, which is the years. So I'm going to go on record as making this comment, and you have 2 choices. You can listen and be wise, or you cannot listen, and as the Word of God says, you can be foolish. So if you were to write this equation and you have everything correct, and on the test you just didn't get the right answer, you're going to get a lot of credit. However, if you choose, like so many students like to do everything on the calculator, then you're not going to get any credit if you get the wrong answer, because I can't see that you put things in the right place. Now, it's extremely important here. People want to go ahead and plug the whole thing in. It doesn't always work that nicely. So let's give you what you're going to do first. What you're going to do first is you're going to do order of operations, which is 0.005 divided by 12. And you're going to get, did everybody get that? Hello? So, divide 0.005 by 12. Then you're going to add 1 to it. What I got on my screen, so you can just confirm if I did it right, I got 0.00416667. Did you guys get that? No, that's before you add the 1. Okay, now add 1. And obviously now you have 1.00041667. Okay? I'm just going to write it in here. And now you're going to take that, again, don't clear anything. Now take that whole thing and raise it to the power of 36. And you should get 1.015109893. Yes? Multiply that, add 1. Take 2. Power of 36. And we're not rounding anything, multiply it by 12,000. And what we should get was 1218132. Did everybody get that? $12,181.32. Okay, so if you wanted to ask me, I don't really think that's a wise investment, because you only made $181 after 3 years. There's a lot of other things you could have put that in. You could have put it in a money market. You could have put it a lot of different places. You could have put it in an annuity. But that is your final answer. Question? Yes? Well, you must have hit something wrong. Clear your calculator. Yes? It says it's compounded monthly. So let's look back over here. Annually is 1, semi-annually is 2, quarterly is 4, monthly is 12. That's how we got it. Does anybody have a question on compound interest? Yes. Right there? Is that a good place? Good job. All right, let me make a comment and just everybody listen up real carefully. How do you know, guys, when to use the compound interest formula and when to use exponential growth? It'll be very clear. The compound interest formula will have keywords like compounded so many times a year at an interest rate, an initial investment of, okay? It'll tell us that is the key difference between that and using exponential growth. Okay, the last type of a problem that I would like to do with you is an exponential decay problem. So if you turn to the next page in your notes, let's just go ahead and look at this really quickly. Writing exponential functions, and our next page in our notes is, here are your exponential growth and exponential decay formulas. One more time, they're just going to be a little bit clearer for you. Let's just change that. An exponential growth formula, again, is y equals a times 1 plus r to the t, or y equals c times 1 plus r to the t. They both mean the same thing. It depends on which math author you read. And it is explaining each part of the formula. That y is the final amount, a or c is the initial amount, r is the rate of change, and you have to change it to a decimal, and t is the time in years. Now we're going to look at exponential decay. The only difference is instead of it being 1 plus r to the power of t, it's 1 minus r to the power of t. Now let's just take a walk for a minute, and let's just look at some things that might decay exponentially. Things that decay exponentially. Okay, so let's come up with some kind of a list here. What could decay exponentially? Anybody? A population. A population could decay exponentially if there was a major war, if there was a breakout in some type of a disease that could actually wipe out a population. So that's a good one. What else could decay exponentially? Yes. Money, your finances. Stock market crash, bad investment. Okay, what else could decay exponentially? Yes. And let's add one more on there, like new cars, new trucks, machinery. They tell you, as you'll get into upper level math and as you take a class in your senior year, I believe, they'll talk about things like you should never buy a brand new car because as soon as you drive it off the lot, it has depreciated. Okay, so let's go ahead and look at the exponential decay formula. The exponential decay formula says y equals c times 1 minus r to the power of t. C is the initial amount. R is the rate of decrease, and you're going to change it from a percentage to a decimal. And T is the time in years. Are y'all with me? Hello? Okay. So let's go ahead and look at this example. The original price of a tractor was $45,000. It depreciated. So whenever you see the word depreciated means decreased or it lost value at a steady rate of 12% per year. And I'm just going to do the problem one time instead of writing the equation and then doing it. What is the value of the tractor in 5 years? You're going to be shocked to see how much it depreciates. So step number one, the first thing you need to do when you read the problem is you need to make a decision, guys. Is it exponential growth, exponential decay, or compound interest? We all agree it's what? It's exponential decay. So I'm going to use this formula. Let's just give you a note here. C equals A. It just depends, again, what math author. It's the initial amount. It depends which formula you want to use. They're both correct. Do you understand? Yes? So what's my initial amount? Good. What's my rate of depreciation? 12%, and you're going to change that to a decimal, which would be 0.12. And what is my time in years? 5 years. So now we're going to set it up. Y equals 45,000 times 1 minus 0.12 to the power of 5. Order of operations, parentheses, exponents. 1 minus 0.12 equals, everybody should get 0.88, correct? I'm writing it here just so you can see it. Let me make a comment. On a test, can everybody look? On a test, this right here is what I need to see. If you hit wrong numbers after that, at least you can get credit that you had the formula correct. So now you're going to multiply, take 0.88 to the power of 5, and you should get 0.527731917. Yes? Multiply that times 45,000. And so, what's it worth after 5 years? I got $23,747.94. Okay? And sometimes they'll just have you round it to $23,748. Okay? I am fine either way. Let me just make a comment and say that on your test, it is free response. Both of these answers are correct. Are you with me? Okay, I do want to give us some time to practice, but for those of you that are listening, I hope that you enjoyed this lesson. This is one of my favorite things to teach. Again, the formulas look a little scary, but formulas will be provided for you on the test. They are in your notes, and we are going to get some work done here in a minute.